this question, we're going to use differentiation to show where a function is increasing and decreasing. So for question 1, because we are finding the derivative as per the subtitle, we are going to find f dash of x. This just basically means we're going to differentiate this function with respect to x. So when we have an x cubed, we just bring down the power, so it becomes 3x. We just reduce the power by 1. A constant with a x will always be differentiated just to the constant, so the x effectively disappears, and then the constant always disappears because we're always reducing the x power by 1. The function is possibly going to look like this, because it's going to have a max and a min. Why do we know that? Well, the maximum power is 3, which means it's going to have 2 local mins and maxes, but we don't know if it looks like this red graph, or perhaps it looks like this green graph. So using differentiation will help. Why? Because when we've differentiated, we now want to see when the gradient is going to be equal to 0. So when these points where I've included a straight line happens. So what we do is we substitute f dash of x for 0, or the gradient function is equal to 0, and we simply solve this equation. You can solve this on the calculator, or you can solve this by using common sense, and the answer is going to be x is equal to plus and minus 1. This just effectively means that a min or max is going to occur at -1 and at 1. But again, we don't know if the graph sketch is going to look like the red sketch or the green sketch. So this is why we're going to be deciding using the next process. How does this work? We are going to do a sign table. So we're going to inspect what happens at both of these x values. First of all, let's pick the smallest x value, which is -1. And then let's inspect the biggest x value, which is +1. So we know at both of these points, the gradient is 0 because we are drawing a flat horizontal line. We want to inspect what's happening either sides of these points. So you could go for one number above and one number below, for example. The differential function will just be filled with positive and negative values, and then an appearance of 2 zeros at these values. So the first step is to simply plug in 3x squared minus 3 into the y equals, then view the table, which is by pressing the second graph. Then we need to see what's happening at each of these values, -2, -1, 0, 1, 2 for x, where you can see we're generating a positive value, a negative value, a positive value. So a sign table just effectively means we write plus or minus here, plus or minus here, and so on. Now, because we've got a pattern of positive, 0, negative, this means that at this point -1, we are going to generate a local maximum, because the shape is a positive gradient, 0 gradient, negative gradient, whereas this is the opposite way around, negative, 0, positive. So this is going to give us a local minimum. Therefore, the graph is going to look like the red graph more so than the green graph. And therefore, we can say that at x is equal to 1, we are going to get a local minimum.